We are excited to have this very intriguing, very interesting topic for our conversation today by my good friends Jim Goodell and Abul Azad. Jim Goodell, as you can see on the slide, is a public benefit corporation called Incredible. He's also chair of the ICT Learning Technology Standards Committee, member of the steering committee, National Consortium for Innovative Collaborative Learning Engineering. This is the emphasis all on about learning engineering. And then Abul Azad is a professor at Northern Illinois University. Once again, he has been associated along with Jim of the IEEE Learning Technology Standards Committee and the Global Online Robotics Consortium. So we have a huge amount of experience and insight into learning engineering. And so the title is appropriate. Is it a crazy idea to use engineering to develop and deliver engineering education? May not be that crazy. It might be something that we might learn how to do. Get started in the presentation today. So over to you, Jim and Abul, go ahead.
Hello, morning or good afternoon or evening, wherever you are now. So in our place or in my place in morning, throughout the process, Jim and me will be talking with you. And of course, at some point, you will have some time to talk with us or on some issues. So before we move into how many of you heard of learning engineering? If you can raise hand on the platform, then we can at least know that what kind of audience we have here.
Okay,
you can keep your hands.
Some hands have gone up.
Okay. Okay, that's good. That's good. So we will mainly talk about how we teach our classes and at present time and the old times. So those are the 5 topics here. First one is the progression of teaching and learning with showing back times and at present time. Then we will talk about having a few of the current teaching arrangement what we have got. Then we come into the topic of learning engineering. What we are going. This is our main kind of topic for this presentation. Then Jim will mainly talk about makeup of learning engineering, or I think in brief we sometimes call LE, and at the end we will highlight some benefits of learning engineering. Okay, please move. So ancient times, usually students went to a teacher's house or wherever he or she lived, and sometimes they lived there for maybe a few years, learn about things about life and all of the things, and then they go back to their place wherever they came from. And then at some point, people are thinking making it a little bit efficient, so they come up with formal way of schooling, where they bring a group of students maybe in a place or sort of classroom, and they give some sort of teaching classes certain time of the day, and that kind of formal thing came forward, and that actually going on for hundreds of years. They said that I just grabbed a few of the images in terms of some part of Europe, they use that kind of model, or if you look at Indian model, little bit same thing. I think both places, they also, apart from teaching some sort of topics, they also talk about this overall health and mind things as well. You can see them. Part of that only actually in the model, Indian model, there's people are doing some sort of exercises or practices and things, so keep their overall well-being and things. So we move forward in time, and next slide we will see a little bit modernized form of classing or classwork. On the top left corner, a little bit earlier time we went through this thing, at least myself, I went through this kind of schooling process. And then picture at the bottom right corner, you can see a little bit of improved one where they're using some of the poster board on the wall and things, and this little similar kind of arrangement, but a little bit improved materials and things what they have got. Next one. So this one is current or modern classroom, which I can say, and on this side of the left one, they're using some PowerPoint, some other graphical means of presenting thing. The student are having access to some electronics to interact, or at least viewing. And on the right side, we are seeing that we learned during the pandemic time that how to join classes over the web. In this one, teacher at home or somewhere and classes in a classroom, and there may be a model where the student may be in the house or any other place and teacher may be in the classroom. So there are various kind of arrangements which we can have. But however, one of the things we are seeing that the teaching arrangement has not much changed. There is a group of people in front of the teacher and teacher is teaching. So that the whole, we are maybe using modern things. There are very little chance for the student to, they can interact, but not much of influence the flow of the class that has been given by the class teacher for whatever it is. So in the next slide, we will see some highlighting points. So these are the top 4 of them are what are the non-beneficial thing for the current model of teaching, or even going back to long time back, that we treat whole class as the same way. But we know that human being learn in various, people learn in various ways. We do not take care of that much. There may be some smaller effort, but not much. So we are trying various things for the whole class and thinking that it might work. And sometimes grade goes better, we feel good. There is no closed loop monitoring of the thing and making some adjustment. So with that thing, there is some disengagement of some students happens, and also student might, they leave the class or course or program even happen. And the 4th point is one of the major one which I want to highlight here. In terms of higher education, we are the teachers, we do not have formal teaching training. We have got our PhD highest. We feel that we learned everything about the world. We go to the classroom, and sometimes we go back to the learning and teaching, what I am trying to do now. However, there is no kind of formal need of it that one has to. Some part of the world, they make it as a partial need. You have to have some training, but at least in our place, US, there is not much burden someone have to do those trainings. So this is one of the shortfall, I think, for this current model. So at this point, learning engineering came into play. So where students' feeling, thinking, or activities will be checked or monitored, and that will be loop will be closed, so that course planning and I think as well as presentation of the course will be changed or improved, and that we can get better kind of outcome. That we'll talk about this thing as we go along now. Okay, Jim, next slide, please. So first, John Doe is here. He is the first person which we found that I found that he was first thinking about education as kind of engineering process. But that is a long time back, 1922. But he felt that there need to be some development of some other areas that this kind of idea can be implemented. So that left there. Let me move forward. Then came his charters. He also come up with the educational engineering in 1945. I put the name of this article. If one can browse, you can find it out. And he also mentioned that there is a need to be some work in this field, but the existing educator we were talking earlier, there is some backlash on those things. So this, until those changes, we will not see some major change in this kind of how we teach us and learn. Yeah. This guy is the one, he is the one who first using the word learning engineering first time, 1967. And he is mainly, he wrote an article. Mainly he wrote about the, this financial matter in this field, but at some point he talked about teaching and learning. He first thought that we teach in the class, but we do not think of much of whether the learning is taking place or not. So that is, he talked about that at that point in time. So next slide, we will be highlighting few major points of learning engineers. He mentioned that learning engineer and teacher or instructor should work as a team, because whoever the instructor who teach, who is in charge of the class may or may not have all of this know-how, how to present the topic in the class, and that one can learn. So they should form a team, and that will bring some effective outcome. Okay, next one. So in 2016, this is the first time actually a little bit more of work done in this learning engineering field. 3 of the individuals from MIT, they wrote a planning for this higher ed field, and one of the parties they're talking about learning engineering. They put some breakdown of learning engineering processes, and this can be, you can think of a current time outline of learning engineering. However, we move forward from there from this point. Yeah, next one, please. So I think Jim will be taking over from here. Jim, please go ahead.
Okay. Thank you, Abul. So I'm going to be talking about the current era of learning engineering, and it really begins in 2018 when the Learning Technology Standards Committee of the IEEE Computer Society established the International Consortium for the Innovation and Collaboration in Learning Engineering, and the work resulted in the first definition of learning engineering. So let's take a look at that. Oh, but first, let me wrap up the history. There was, back in 1967, the first time the term learning engineering was used by Nobel laureate Herb Simon at Carnegie Mellon University. And then 50 years passed. So it wasn't until, so in 2018, ISICL was founded. And in 2019, our first conference in the learning engineering definition was adopted. But that was also the beginning of some pretty significant institutions paying attention to learning engineering. Institutions like MIT and Carnegie Mellon University, Arizona State University, Boston College, University of Central Florida, Vanderbilt, are all paying attention to learning engineering. The U.S. Department of Defense, Boeing, large companies like Boeing, Houghton Mifflin, Underwriters Laboratory, and Legion, and nonprofit organizations like ACT Educause, IEEE Education Society. There's also been, I've also had the opportunity to be at a UNESCO meeting and at a meeting of the Partnership for Peace of some allied nations connected with NATO, and they're also interested in learning engineering and adopting the process and practice to improve what they do in both education and training contexts. So some key milestones, we published the Learning Engineering Toolkit in 2022. There were 29 authors on the toolkit, but it wasn't a book that just had 29 separate chapters that were written in isolation. It was a team effort, and there's a lot of there's cohesion across the first part of the book is about the foundations of learning engineering, and the second part is sets of tools, process tools to use to actually do learning engineering. And I think another key point in time was when the U.S. Air Force decided to stand up the Enterprise Learning Engineering Center of Excellence. The U.S. Department of Defense, I think, is the largest training organization in the world. So this was significant for learning engineering. So here's the definition of learning engineering that it was adopted by IEEE. Learning engineering is a process and a practice that applies the learning sciences using human-centered and engineering design methodologies and data-informed decision-making to support learners in their development. So we think of learning engineering as needing to have all of these ingredients. You'll notice that we're not saying that it's about a single person, a learning engineer, but a process and a practice. And we'll get more into the team a little bit later. It's an engineering process. It's repeatable and it's iterative. And the systems engineers in the audience will recognize this diagram as a closed loop control system. So let's take a look at the specific process of learning engineering. It is contextualized. You can see on the outer circle of this process model, the word context. You can see the word learners, because learning engineering is done in a learner-focused way. We also consider who is the team doing the learning engineering and what are the resource constraints on that team. The learning engineering process starts in the center. It starts with a challenge or a problem to be solved. So it's goal-oriented. Where it goes next depends on the nature of the challenge. In some cases, we have a current curriculum or content or learning system that we want to improve. So we might go to the implementation stage and collect additional data so that we can figure out how the system might be improved or the content might be improved. We may have some data and we don't understand where the opportunities are, so we go to the investigation stage, or we may collect more data. But let's say we're creating something new and we have enough data to understand the challenge before us. So we go into the creation stage. The creation stage itself is iterative. And you'll notice that as these stages come up, the word data is in each of the stages. In learning engineering, creation is not just creating course content, such as an online course. It is also concerned during the creation stage about instrumentation, and that's the fancy word for how we collect data about learners interacting with our content. And we also want to create some implementation plans. We want to understand how the content will be implemented. and in what contexts. So that's part of the solution. As we move into the implementation stage, which we want to do as soon as possible, we want to get prototype and early models of our content or solution in front of learners as soon as possible so that we can collect some data and see what works and what doesn't work. And then we investigate those data and identify ways to continuously improve. That's essentially the learning engineering process. But this model is also a closed loop control system. This shows that learning itself is a closed loop control system. So in this case, we're showing two loops. The outer loop are things like selection and assignment of learning experiences. And the inner loop is the loop that can take place while a learner is engaged in a learning activity and giving immediate feedback to the learners. So let's unpack this ingredient, the learning sciences. Like any field of engineering, the learning engineering applies scientific knowledge. And some of the science behind that Abul alluded to in his part of the presentation earlier in talking about tailoring to the needs of students. We know from the learning sciences that people learn best when they have the right level of challenge in the learning. So there is a concept called the zone of proximal development, which is the point that is just beyond what a learner can do without help, just out of reach. And that's kind of a sweet spot for optimizing learning. In a traditional classroom model, it is very difficult to give all students that right level of difficulty. And in the past, hundreds of years ago and 100 years ago, our education system was mainly a filtering system that those that could stick with it and pass the tests would go on, and those who could not would not go on. We're living in a world where the expectation on education is more that we help all learners succeed. And that kind of brings me to Daraja. I don't know, Devar Raj has a question in the comment. I'm sorry if I pronounce your name wrong. What do you feel is the best teaching method for higher education, chalk or talk, or using audio-visual aids in the class? And I would say it really the best modality of learning depends on where the learner is in this progress from moving from novice to expert. They're at the beginning of the process, exposing to new concepts like we're doing today. This expository learning is important. Later on in the process, this is not very effective. Lectures are less effective, and practice is more effective. So ideally, what happens is learners are exposed to new concepts, and then they're given more active learning experiences later on. I'll take more questions as we move on, but I want to get through this section on the learning sciences. So let's talk about some aspects of the science of learning. One of those areas is expertise, which I've already started with. I thought that was a good lead-in to this. Um, what we know from the learning sciences is we have both working memory and long-term memory, what Daniel Kahneman calls System 1 and System 2. And working memory is slow and short retention when people can only have kind of conscious awareness of 3 to 5 things at once sometimes. There's a concept called cognitive load where we can't process too many things in working memory at the same time. But it is highly flexible and it's the place where new learning happens. And then there's long-term memory, and that's kind of what experts use. So a goal is to move from working memory to long-term memory. Long-term memory has long retention, and it is highly parallel. You can do multiple things at once. It's sometimes unconscious. I think of I learned to drive a car a long time ago, and for those that drive, the it's or ride a bike, it's something that you can do without thinking too much about. And sometimes I will be traveling somewhere and thinking about other things, and I'll realize that already at my destination, and I have not really thought too much about the driving process because it's in my long-term memory, and that system one thinking kind of takes over. So also forgetting, there's a lot of science about forgetting. And I like to tell a story. Back in 2018, I visited Duolingo. Um, if you would, raise your hand if you have used Duolingo, the language learning app. Okay. I don't see any hands raised. Okay, so Duolingo is a pretty widely used app here in the US. It's for learning other languages. And one thing that I discovered when I visited Duolingo is that they are able to predict your future. When you use their app, they can predict when you're going to forget a word. Could a volunteer put it in the chat? When do you think is the optimal time to practice a word if you're learning a new language? A word that you've already practiced in the past.
Let's get people on the chat here about that question.
I'm sorry, I didn't.
Optimal time. Optimal time.
Yeah, the optimal time. Is it 1 week or early? Okay, early morning. Yes. Okay. While traveling, office, same day. Okay. So yes, there is an aspect of chronobiology that comes into play, that some people tend to learn better at different times of the day. And of course, any time that you have downtime is a good time to practice. What Duolingo discovered, and this comes from some century-old initial research, same day morning. The research goes back to a German researcher, Hermann Ebbinghaus, who discovered that what we all know, that people forget things over time, but he wanted to predict how quickly he forgot things. So he tried to learn some nonsense words and experimented with how quickly he forgot these nonsense words. And he found he could predict. And he came up with this concept of forgetting curves. Well, Burr Settles, who's pictured on the right, built on this research and lots of other research that has gone on since. And what has been discovered is that the best time to practice something is just before you forget it. In the case of language learning, one reason why it is best just before you forget it is because you can be using the time leading up to that to learn other words, and then just before you forget the word, if you can get some practice and reinforce that, you can optimize your time learning. So Burr came up with a model, an AI model called a trainable spaced repetition model, and that was the basis of the AI used in Duolingo. Some other aspects of science, the science of retention, of remembering things, has to do with the fact that learning is multidimensional. So we can think of all of these different factors: the quality of teaching, what kind of academic support, engagement and involvement, the sense of belonging, early intervention, other external factors like social integration and pathways and goal setting, financial support, student well-being, and practical application of knowledge through internships and so forth. So all of these things can be considered problems to be solved with learning engineering. The 5 factors at the top of the list might be more readily accessible to the enhanced retention rate, but really all the factors might have some impact. So let's take a look at one more area of the science of learning. There's too much that has been discovered in the past 30 years about the science of learning that for us to go into today, but motivation is an often overlooked aspect, but a very important aspect of learning. So there are multiple factors involved in motivation, factors such as value, the learner understanding the value of what's being learned, self-efficacy, which is the learner believing that they can achieve the learning, attribution errors, which has to do with when a mistake is made, is the learner willing to accept and adjust what they're doing, or are they blaming someone else? And emotional aspects will affect motivation. And motivating actions of the learner is starting, persisting, and mental effort. There are also motivating operations. We have an entire chapter in the Learning Engineering Toolkit on motivation. And motivating operations are what external things can be done to help improve learner motivation. And that, of course, affects positive or negative learning results. So here are some of these factors, and I've already described them, so I won't read this slide. This slide presentation will be available after the presentation so that you can refer to it later. So we already mentioned that learning engineering is not a person, but it's a process and a practice. So it's a team sport. So what I'd like you to do now is put in the chat how many of these areas of knowledge that do you think that you have some level of expertise in, maybe not an expert, but have some knowledge in order to practice at some level?
Well, let's see how many we come up
3.
with.
2,
Awesome.
3.
Okay, how about others? How many of these do you think you?
Just remember.
Okay.
I think one of about 5. That's good.
Yeah,
Okay.
that's good.
Yeah.
Hmm.
So in all of the times over the past few years that I've given presentations, I think there has only been one time that I've ever come across a person that said they had a background in all 8 of these areas. So it's very rare for any one person to have working knowledge of all of these domains. And that's why learning engineering needs to be done as a team, because in many of the challenges that learning engineering teams face, it requires some knowledge in these domains and sometimes some other domains that aren't even shown here. So we need to form the teams that can help us get the job done. And what's really important for these teams to work well is a shared understanding. Because in some of these domains, the same words are used to mean different things. So if there isn't that cross-training, if there isn't some shared knowledge about what the other domains use, how the other domains define things, and I think of domains like assessment and psychometrics versus instructional design, for example. There are some terms that just have some different meanings. Being able to understand each other and work together is really important. And we also consider learners often to be part of the team. Learning engineering is not something done to learners, but it's accomplished by and with them. And we do that in ways like getting early prototypes of content or systems in front of learners as soon as possible, sometimes inviting them into design sessions, representative sample of different personas of the learners to be served. And that gets to the human-centered aspect. So I'll try to address both the human-centered and the engineering design aspects in the next part. There are many factors that impact learning. There are cognitive factors, there are motivational factors, there are temporary factors such as fatigue and the motivation that a person has on a given day based on what's going on in their life. If we're going to optimize learning for our learners, we need to take all of these factors into account. And we can draw on a number of areas of research, such as human-centered design and ergonomics and human factors. And they can contribute to improving how we address all of these factors. So I'll talk a little bit more at the end about some engineering principles that have been adopted by learning engineering, but first I want to get into data-informed decision-making. There are really 2 main things that you need to know about data-informed decision-making in learning engineering. The first is to get data, and the fancy word we use for that is instrumentation. So we can directly observe some things like the instruction that's happening. We can observe a learner's interactions with that instruction. We can observe assessment events, quizzes and exams and surveys. But we can only infer that learning events inside the learner's brain are taking place. But if we have good data on the directly observable learning events, then we are able to infer that knowledge components are being developed. So instrumentation fits into this closed loop control system. If we use sensors to capture data, and that involves both software and hardware sensors, we can process data for analysis. Here's a view of the kinds of sensors that we can use with online learning. It's really any digitally observable learning experience can be instrumented. Even classroom-based learning experiences. Carnegie Mellon uses video in the classroom and audio analysis to give feedback to instructors, for example. But any hardware device, such a tablet, a mouse, or a keyboard, or video, or audio, or a virtual reality, or eye tracking glasses for AR, can all be sources or sensors to capture these kinds of data. And we use software sensors to add context. Who performed the action? What action was performed? What was the context of the learning activity? And what result came from that action? There's an IEEE standard for instrumentation called XAPI or Experience API that is widely used. And we can transform the data into the formats that we need to do different kinds of analysis. This can be analysis within an adaptive instructional system to give immediate feedback to learners, or it can be used by learning engineering teams to as a feedback loop to continuously improve the learning experiences. So that gets to using the data. In the Learning Engineering Toolkit, we have a learning analytics process model. It starts with what questions do we want the data to answer? Then we ask, do we have the data we need to answer the question? If we do not, we need to instrument to collect the data. And then there's one more step before we do analysis. We need to translate the real-world question into data questions, such as which student needs an intervention? Or which student will we give a learning intervention to? The data questions may break that down into two different problems. One, how do we predict which learners can benefit from an intervention? And then where do we cut off the intervention? Because it may become too costly to give the intervention to too many learners, for example. Once we have the data questions, we can do things like predict, infer, or mine the data for patterns that can help us understand what to do next. I'm going to quickly move on, but this learning analytics process model will be available through a QR code later in the presentation. One kind of analysis that learning engineering teams can use is called learning curve analysis. One way that this is used, if you have a collection of formative assessment items and you assume they're assessing the same thing, what should happen with a group of learners is the error rate should go down over time. If it doesn't, then we know they're probably is something wrong about our assumptions about that set of learning experiences, that maybe they're not assessing the same thing. And I'll leave you with this. If you're interested in learning more about learning analytics, a great resource is this Big Data and Education massive open online textbook that's for free, and it's available from University of Pennsylvania. And this is the work of Ryan Baker. Okay, so we're going to finish up now with some questions. The first question is, what would it take to implement learning engineering within engineering education? I'd invite you to either put your thoughts in the chat, or we could call on, raise your hand, and we could ask you to come off mute to.
Yeah, we can do it. Text or raise your hand. Let's call on the person raising your hand. What would it take to implement learning engineering? If then engineering is something coming up on the path.
Okay, so we have lots of hire or add roles from the learning engineering team. So yes, it's you don't necessarily have to hire and add the roles. Sometimes you can engage with people from other departments within a university, or engage with a community like Icicle. Sometimes it's just a small amount of time that's needed rather than a full-time person to be part of the team. I see some other, skip around here to some others. Intrinsic motivation. So yes, intrinsic motivation and so there's intrinsic motivation is the most effective kind of motivation. There are some motivating operations that can catalyze intrinsic motivation. So I won't get too much into that, but there's a chapter on that in the book. Systems approach to engineering education. Yes, that's a great point, is that it's a mindset shift from thinking of engineering education as pouring knowledge into students' brains to more of a system perspective. Yes, capturing data. Any way that you can capture data is a step in the right direction towards learning engineering. New ways of learning. Be interested in hearing more in your thoughts on that. But one of the learning science discoveries is that that there isn't one best modality of learning, visual or audio or kinetic, that it's really multimodal that works best. So having good visuals along with good spoken is better than having one or the other. I see open learning, new techniques and new technologies, helping learners adapt their mindsets. Yes. We most often conduct written exams, and students concentrate on scores than learning experience. That's right. So I think one way to do that is to try to shift more to a practice-based model, and we have technology now that can help us do that. So maybe multiple universities work together on, for certain domains of learning, work on simulations that can be both the learning place for learning and a place for assessment. And rather than a one-time exam, it's better to track learning over time on that continuum from novice to expert. Iterative design, yes. Engineering education is a path to learning engineering. So I guess that's a follow-up question. How do we get learning engineering into schools of engineering education? And I see focusing on integrating learning science principles. So I guess part of that is informing educators of what we've discovered about the learning sciences in the past 30 years. And real life examples, yes. Worked examples is shown to be more effective in some cases than high cost production of videos or other high cost learning content. Okay, so we have some considerations, which I think can spur some additional follow-up questions. Project-based learning, yes. So what human resources and skills are necessary? And so I'd like you to think about your own practice. What additional domains of expertise would you like access to as you develop learning experiences and the ideal conditions to help all of your learners succeed?
Good question.
Okay, so expertise in understanding the technology that can be applied, technology trends and engineering habits of mind, going beyond the content knowledge to habits of mind and behaviors. Yeah, asking questions is great for it's a more effective form of learning when learning is more active. Analytics, educational data scientists. So I think one step forward, rather than each educator bring together the full team that we saw earlier. Some universities are putting together teams that assist all of the instructors in the university with these different areas, such as data science and learning science, and yes, creativity, problem analysis. So having the team accessible when needed and helping to keep instructors informed of latest both technology and learning sciences and opportunities to use data to inform iterative development. I see that we're running out of time, so I'll move on.
Yeah, okay. I think we're gonna give Michael out a few minutes at the end to make some comments. Michael out from IGIP.
Yeah.
When you're done, Tim and Abul.
So I'll just skip to, you can take a look at this slide about one of the tools that are available, and I'll leave this slide up. So there are some free resources that are available in a folder that's hosted by IEEE Icicle, and I also have the QR code for the book, Learning Engineering Toolkit. But let's stop now and have some discussion or wrap things
I
up.
want to add one thing here, Jim, that I think one of the thing what we can do easily that not much of effort, that whenever we planning for a course or we are giving a course, try to involve some students' input in the process. That could be a big help at first place. So and nowadays, what we do, I don't know, most of us, we plan our class and we go over the class and maybe having some evaluation at the end of the course or in the middle. But there is not much of say of the student, how they want to see this course. So that could be a very basic thing which you can do with very minimum effort.
Yeah, one thing that I find very intriguing is my latest understanding of brain science, okay, in a very amateurish way. The fact that chunks of information go into short-term memory, and that we have to keep actively learning, using that information in order to go into long-term memory, which says that the whole model of teaching, so you have 50-minute lectures or 1-hour lectures, should be thrown away. We should just have 10-minute lectures, plus an activity, another 10-minute activity, and that could make a significant impact on learning. What do you think?
Absolutely. That's the if we redesign learning based on what we know from cognitive science, it would look a lot different than what it typically looks like these days. Okay, so I'll stop sharing now.
Okay, great. I'll let Michael speak for a couple of minutes, and then anybody else, you have time for any other couple of questions, let's open it up. Michael, go ahead.
Okay, thank you so much. I have another meeting at 3 o'clock my time. Therefore, let me say some words here. First of all, Abul and Jim, thank you so much for your interesting presentations. I learned a lot again, and I didn't know what all you do in your committee, in the IEEE Education Technology Committee. It was very interesting. But frankly, one thing, I was a little bit surprised about your historical outline. Maybe you know, we had in Europe, or we have in Europe, especially Austria, Germany, already university courses in engineering pedagogy for many years, 50 years already. In 1972, the EGIP, the International Society for Engineering Pedagogy, has been founded. And since there is also available a prototype curriculum in engineering education. There is also a global certification program that has been completed by over 20,000 engineering educators. And we cooperate also with Krishna, for example. Just in January, we had a group of, I think, 30 people who received the certification. It's not time here to explain this in much more deep. I think we had already from our president, Tia Rüdman, a webinar in the series last year, or maybe also 2 years ago, I don't know. But my suggestion is, and perhaps it would be a good idea to bring EGIP and your committee together. Maybe you have a meeting of the committee and we can give a presentation there, or you give a presentation in one of our committee meetings, or we meet during the conference, for example, IUCEE conference in June could be also a good place. So my invitation is let's come together and maybe we can do something together. Thank you so much.
Yes.
Collaboration is great. So I'll let Jim and Abul wrap it up.
Yeah.
Yes, let's do that. We
Thank you.
learn from each other, and yeah, please reach out to me, Michael, and we can set something up.
Okay, thank you so much.
On that note, I think we should close because we're right on the dot here. Thank you so much, Jim, and of course, it's been a very, very enlightening session, and you can see from all the chat discussion that you really got people interested, excited, and learning a lot from what you're saying. And everybody, thank you all for joining and staying for the whole hour. And
Thank you for providing us the opportunity to talk to all of you. Thank you.
Prasad.
Have-
Thank
good
you,
night,
Jim.
have a good afternoon.
Bye.
Thank you.
Appreciate it.
Bye.
Bye.
Hello, JC. Bye.
bye.